some of this. We already did our degrees and radian thing, but what we didn't talk about was calculating arc length, linear speed, and angular speed. So when we calculate arc length, you probably have actually done this before, because arc length is basically going to be calculating some fraction of the circumference. And the way we do, and that's what this S represents. The fraction of the circumference is determined, here's our radius, but it's determined by the angle. And the radian measure of the angle tells you how much of the circle you've gone through. So if this were angle 2 pi, then you would have gone all the way around the circle, so that would have been your arc length, 2 pi r. You guys remember this? For your choice. But if you only go 3/4 of the way around, then it would be 3/4 pi. Or no, it'd be 3/4 of 2 pi, which is 6/4 pi r. But the angle here tells you how far you've gone around, and that's why we need it to always be in radians, because the radians are what tells us how far we've gone around the circle. It's not the degrees that tell us that. The other thing it needs to be is non-negative, because we can't have negative lengths. We have to talk about how far around the circle we went in terms of distance traveled around the circle as opposed to directional. So it needs to be a non-negative radian measure. Now, linear speed. Well, normally when you find speed, what do? When you figure out what your speed is, what is your unit of speed in your car? Miles per hour. We talk about how far we went per an amount of time. Well, that's what this is going to be. Our linear speed is how far we went around the circle divided by how long it took us to go that far. So if we went around the circle 3 times and it took us 3 seconds, then it's whatever the 3 times, depending on how big the circle was, we would put in our radius times 3 times around the circle divided by 3 seconds. So we're moving pretty darn fast. Then, angular speed is different. Angular speed is asking about how quickly our angle is changing as we go through our rotation around the circle. This thing is actually an omega. We start getting Greek letters in when we do trig. So,
can you write that on the board, please? We can't see it. Please.
So our angular speed, is omega equals theta, which is the same theta as up here, a non-negative angle measured in radians, divided by time. So how fast our angle is changing divided by how long it took to do that change, or how big our angle was divided by that. We don't usually in this class deal with angular speed very much, and we only just hit on the other two, the arc length and the linear speed.
So our theta is our angle measure.
Theta is the angle measure, non-negative radians. All right, so we already did our converting from degrees to radians. Let's do an arc length problem. Find the length of an arc on a circle of radius 6 inches, intercepted by a central angle of 135 degrees. So what was our arc length formula? S equals R times theta. Okay, this should be pretty easy. What's R? 6. What's theta? It's not that easy. Theta is not 135, because what did we say about theta?
In radians?
It had to be in radians. This is in degrees, so I have to change 135 degrees into radians. multiplying it by 1 so that I get rid of my degrees and end up with radians. What will need to be on the top in terms of units and what will need to be on the bottom in terms of units?
Radians on top.
Radians on top. That means degrees must be on the bottom. In this class we did that pi was equal to 180, is that right?
Yeah.
So it would be pi radians over 180 degrees. So when I multiply it together, I get that my angle measure is 135 pi over 180, which you can simplify if you really want, but you don't have to, and that's in radians. Now one of the cool things about radians is they seem to just disappear when we multiply them times inches. So it's kind of like it's just 1 unit circle radius, so it's a length and it just kind of goes away. So I'm going to multiply this times 135 pi over 180, and what I'm going to end up with is inches. So approximately how many inches is that?
4.5.
How many?
4.5 times pi, which is
So this is approximately 4.5 pi inches, which is going to be somewhere around 13, 14 inches. 14.14. I was thinking 13 was going to be just a bit small. So that's not that hard. The part you have to remember though is invariably we give you the angle in degrees, and you're going to have to first change it to radians to be able to plug it into the formula. Now, I have a Ferris wheel. It's a big Ferris wheel. Its radius is 30 feet. And it's rotating at 3.5 revolutions per minute. Find the linear speed in feet per minute of a seat on this Ferris wheel. Okay, what was our linear speed formula? V equals S over T, and our S was R times theta, and then we're going to do this by T, divided by T. All right, what's R for this problem?
30.
What's R?
30.
30. The radius of our Ferris wheel is 30, right? What's theta for this problem?
We don't know.
Well, 3.5 times 2 pi.
Why?
Because it goes all the way around the circle 3.5 times
In how much period?
in 1 minute.
So, by the way, this is going to be in 1 minute because that's how long it takes to go around the circle 3.5 times. So our poor little guy is sitting on this Ferris wheel and he's going 1, 2, 3.5 in 1 minute. So we're asking what angle did we just go through? Well, we went 2 pi once, and then a second 2 pi, and then a third 2 pi. We're now at how many pi's? We're at 6, right? And then we went another half a pi. I mean half a 2 pi, which is a pi, so we're at 7 pi, also known as 3.5 times 2 pi, because we went 3.5 times around the circle, which turns out to be 7 pi. So now I can put this into my formula, and I'm going to get that V is equal to 30 times 7 pi divided by 1, and is that feet? Yes, this is feet per 1 minute, because that's what I know that happens in 1 minute. So what is that? Does everybody agree with the 659 part? Yes? No? So that's 659.7345 feet per minute. We wondered why I said he was a poor little guy. He's really going fast around that Ferris wheel. Anybody think of that as being fast, or you guys didn't notice?